Hi students, in this video I'm going to talk about the investment involving risk. Uh, so far in our earlier videos, I talked about the cash flows from projects uh, without even talking about whether those cash flows can be found out with complete certainty or not. Uh, and that silent meant that whatever cash flows we calculated from projects were assumed to be known with complete certainty. And we discussed about measuring the economic worth of project using net present worth, annual equivalence, internal rate of return, and also talked about selecting the best ones to invest in without even considering whether those cash flows are actually possible or not. However, in reality, cash flows are not known in advance with absolute certainty in most cases. I would say in almost all the cases. Thus, the concept of risk is required to be introduced in order to deal with cash flows that are not known uh, in advance with absolute certainty. And in order to deal with such investments involving risk, we can use the term project risk to refer to the variability in project's net present worth. In fact, the variability of cash flows each year and in turn the variability of project's net present worth. A greater project risk usually means a greater variability in project's net present worth. If you see this figure here, you can see that the investment A, there are two investments, investment A and investment B. In case of investment A, you can see that the return which is measured on the horizontal axis, and probability along the vertical axis. You can see that for the investment A or project A, the return is varying very closely from its mean here. So the project investment A has a mean of 10% return here. The mean return for investment A is 10%. So about this mean on the left and right, it is varying by small amount. So the lowest return is around -5 and highest return is around 30%. Whereas in case of investment A, although the mean return is high, which is 20 here, compared to the investment A, the mean return is 10. Although investment B has higher mean of 20% return, its variability is very high. You can see the return on investment for project B is varying from -30 to 50. So if we try to assess the riskiness of these two investments, since investment B has higher variability, investment B is considered to be more risky compared to investment A or project A. So in terms of the variability of the outcome or the return, then project B is considered to be more risky compared to project A. Since the variation of return in case of investment B is high, the variation is ranging from -30 to 50% compared to -10 to around 30% for investment A. Now, in order to evaluate the risk of projects, there are three methods: sensitivity analysis, break-even analysis, and scenario analysis. So using these three analyses, we can actually describe the riskiness of a project, or Not only that, we can also actually find out the probability of the net present worth of a given project, especially in case of scenario analysis. In case of sensitivity analysis, that may not be possible. What I mean is, in case of sensitivity analysis, the probability, the calculation of probability of net present worth is not possible, but in case of scenario analysis it is possible. But from sensitivity analysis we can see the variation in the net present worth uh, by plotting graph and see and find out actually which input variable has more effect on the net present worth of a given project. So as I mentioned in the earlier slide, there are a number of factors or variables that affect project's cash flow, like the total market size, the market share, the growth of the market, the cost of production, the selling price of the product, the span of the product, the lifespan of the product, the cost and lifespan of the equipment, effective tax rates, and so on. And these factors are, each of them are in fact variable and do not remain constant over the life of the project, and because of that a change in any one of these factors or variables would lead to the change in the amount of cash flow every year. So that way the cash flow is every year's cash flow is never predictable, 100% predictable. Because all these factors or variables are subjected to uncertainty or subjected to change, and thus the net present worth of a given project may not be what we estimated before after at the end of the completion of the project. Not only that, some items or some of these variables have greater influence on the final result than others. In addition to the degree of in addition to the variability of the degree of variation of each of these variables or factors. So as we mentioned, one way to get a sense of the possibility of outcomes of any investment is to perform a sensitivity analysis. Uh, what this analysis tries to do is determine the effect of variation in the input variables such as revenues, operating cost, and so on, that are used to estimate the after-tax cash flow on the net present worth. So, from sensitivity analysis, we can find out how much the net present worth could change in response to a given change in an input variable. And you can see this from the example in the later slides. Also, from this analysis, we can easily identify and segregate factors that are more significant from those that have less effect on the net present worth from the mere sight of the graph plotted for the values uh, of the sensitivity analysis. So, the sensitivity analysis is sometimes called what if analysis because it provides answers to such questions as what if incremental sales are only 1000 units instead of 2000 units, and because of this, what will be the net present worth, and so on and so forth. Okay, so before we go into the sensitivity analysis, we need to talk about maybe we need to go back to what we did with the calculation of net present worth from the cash flows that we generated in the earlier videos. So if you try to recollect so far, what we have done was that we generated single number estimates for each of the uncertain factors and then calculated project outcome in terms of single net present worth, annual equivalence, or rate of return. That means what we did was, in the calculation of the cash flows in our earlier video, what we did was we took only single values for all these factors which you saw here, these factors. So the factors here are the same factors that you saw here. Okay, so in our earlier project cash flow, what we did was we only took single values for all these variables, which in fact are variables, but we only took single value. Like for example, initial market was market size was 175,000 Newton in terms of Newton, not in terms of units. Market growth rate, we took it as 5%, and unit price we did not even consider. Unit variable cost were 60,000 plus 20,000, and so on and so forth. The salvage value that we took was 45,000, and so on. With that, we calculated the cash flow for each year over a period of 5 years. But the cash flow that were generated with this kind of method has a drawback, because we do not know whether the cash flow that we generated, as you see here, this is what we did in the earlier videos. So we have these cash flows here, cash flows for year 1 to year 5. You can see the cash flows generated. So these cash flows generated, we do not know whether these cash flows will actually happen, and we do not even have the probability of each of these cash flows occurring. Yeah. So since the actual cash flows are so difficult to estimate accurately, what we could do is we could consider a range of possible values for each of the factors affecting the cash flow. And using that, then we can try to generate 3 sets of cash flows. Or in other words, taking a range of values for individual cash flows, range of values for each factor, we can then generate a range of values for individual cash flows, and from that we can also determine a range of values for net present worth, annual equivalence, internal rate of return, and so on. Okay, so this is what is being done here in the second table. For each variable, a range of values is taken, as you can see here. For initial market size, the range of value taken varies from 1000 to 2000. So we are taking, for each variable we are actually taking 3 values: low value, most likely value, and high value. Okay, Similarly, for other variables, low value of 3%, most likely value of 5%, high value of 8%, and for each variable we are taking uh, these range of values considering certain situation like what could be the lowest value of initial market size, because we do not have the we cannot uh, say with 100% certainty that initial market size that we can actually we can actually concur will be a 1500. We do not know. So because of this, what could be the lowest possible value for initial market size? And on the higher side, what could be the highest value of initial market size? So taking an estimate of the value for each of these variables, we can then calculate the cash flow for low set of values for each of these variables. We can calculate cash flows for most likely values of each of these variables. We can calculate cash flows for high value of each of these variables. Then from this we can actually get a range of net present worth by finding out the net present worth for the cash flow generated using these values for these factors or variables. We can calculate net present worth for cash flows generated using these values for these variables. We can also calculate cash flows net present worth of the cash flows generated using these values of these variables, and we can have then three net present values using this data, which will give us the lowest possible or expected net present worth, most likely net present worth, and highest value of net present worth. So we can have a range from lowest net present worth to highest net present worth. So we can, from this we can see that or we can assume that our net present worth can vary from the lowest to the highest. So that way actually from this we can actually uh, uh, make a decision from the possibilities of the net present worth between lowest and highest, and accordingly we can have the confidence for making decision. Okay, so in order to deal with the variability of the outcome of the project, uh, usually three estimates are prepared, which you saw here. Okay, so for each set of variable we can actually generate cash flow. Cash flow for these values of these variables, cash flow for most likely value of these variables, cash flow for high value of these variables. So here is an example of cash flow based on most likely estimate. So in the most likely estimate we were taking initial market size of 1500, market growth rate of 5%, unit price of 80,000, unit variable cost of 60,000, fixed cost of 8 million, salvage value of 7 million and million. So using these values, then we calculate the net income. Okay, so unit price 80,000. These values are in terms of thousands, as you see here. Okay, so 80 here represents 80,000, so in terms of thousands. Okay, so 80 means 80,000 here, 80,000. So 80. Demand initial market size was 1500. Here you can see 1500 units. Okay, the growth rate is 5%, as you see here. The growth rate is 5% here. Okay, and so on. So unit price is 80%, 80,000 Newton. So demand, which is the initial market size, is 1500, and the growth rate is 5%. So the demand is growing every year by 5% over the previous years. So that is why the demands are changing from year to year, 5% compounded annually. Okay, and the sales revenue is equal to number of units demanded into unit price. Okay, so that is how you get the sales revenue. Then you have the unit variable cost, which is 60,000, here. Yeah, so unit variable cost is remaining constant. And the variable cost is changing as the number of units produced is increasing. Okay, unit variable cost is equal to 60,000 into 1500. So here the unit here the variable cost is 60,000 into the increased demand 1575, and similarly for others. So rest of the calculations, the fixed cost is constant 8,000, actually 8 million. So depreciation, so subtract all this variable cost, fixed cost and depreciation from the unit sales, and then you get the taxable income as 14,140. So calculating the tax of 40% and subtracting the tax, you get the net income. Okay, and similarly for others. Okay, so the sensitivity analysis actually begins with the base case situation, which is the most likely estimate here. Okay, cash flow using the most likely value of the factors or variables affecting the project cash flow. Then we can change specific variable of interest by some percentage above or below the most likely value while holding other variables constant. Okay, so for each specified percentage, calculate the net present worth. Okay, and proceed like that. Okay, so you can see one example here, the present worth calculated using most likely value of the variables, which is 11,107. Okay, so I think I will stop here and continue in the next video. Thank you.